All right, so today we're looking at areas of triangles and quadrilaterals. You guys already know some of these formulas, so before I move to the next slide, I'm just going to give you a heads up. Don't copy down two of the formulas. I'll point out which ones, because you already know them. It's just going to be a waste of our class time, basically. It's just a reminder. You guys already know. How do you find the area of a rectangle? Base times height, right? How do you find the area of a triangle? What's the formula for that? 1/2 of the base times the height. So you already know that, okay? So on this next slide, please do not take the time to write these down. You already know these. These are just a reminder. This one is the one that you should copy down, okay? So the area of a parallelogram is the base times the height, meaning the whole entire base side, not just part of it. And then the height is talking about that perpendicular distance. One thing to watch for you guys is when we're looking at the height of any figure, we always mean that straight up and down perpendicular height. You can kind of think about it as, pretend like this is a building. Pretend somebody built a building in this shape and asked you how tall the building is. Would you tell me that this distance was how tall the building is? No, you would probably tell me that straight up and down distance, right? That's the same thing when we're using these formulas. It should always be like a building. How tall is the building? Think about it like that, okay? It is a crazy looking building. I bet that there's crazier out there though. All right, for example 1, we're just going to review area of a triangle. I did give you kind of the goofy looking one, right? So usually we have our perpendicular height drops down inside of the triangle. Here's one where it drops down outside. Does that change anything in the formula? No, it does not. You still go about the formula in the same way. So you still start by looking at, what is my area formula for a triangle? What is it? Okay, I like to use 1/2 base times height in case that there's fractions. So base times height divided by 2 would work just fine in this case because there's no fractions. I will always use 1/2 base times height just in case there are. Okay, so when I'm looking at this, you guys, what is the base of the triangle? Should it be this whole distance right from here all the way out to my 5, or is it just like where the triangle is? Very good. That's kind of one of the other misconceptions, is people want to go all the way out. But it is just the actual base, what is sitting on the ground, of what part of the building sits on the ground. Think about it like that, okay? That's your base. That's 4. Times your height. Remember, you're not telling me the slanted distance. You're telling me how tall is it just straight up and down, which is 5. And again, it's okay that that drops outside of the triangle. That does not change the fact that it's the straight up and down height. So that is still going to be times 5. Okay? When you're doing this work, we only take half of one of the numbers. We don't take half of everything, because multiplication doesn't distribute through multiplication. It only distributes through addition or subtraction. So which number is it easier to take half of? 4 or 5? 4. So what is half of 4? So I'll knock that down to 2 times 5, which is 10, and you're done. Are there any questions on finding the area of a triangle, especially in this type of a case? No? Okay. So the next example we want to look at, we want to find the base of a triangle that has an area of 48 and a height of 3. Why is this different from the last one? Because, yeah, exactly. This time you know the area rather than the base and the height, right? You know the area and the height. Do you use a different formula? Absolutely not. You just use the same exact thing. You're just filling in different pieces of it. So we're still going to start with the fact that the area of a triangle is 1/2 of the base times the height. It's just that we're filling in different letters. So in other words, do I have something I can fill in for A? Yeah, this time I know the area. It is not my unknown. Equals 1/2 times, do I know the base? Not yet. Do I know the height? All right, so now I just have one unknown that I need to find. I need to isolate this b value and get it alone. How can I do that? What's the first thing you guys want to move off of that? Which number do you want to move? The 3? All right, how would I undo the 3 on that side? Yep, we would divide by 3 on both sides. That would leave me with 16 on my left-hand side, and then I still have a 1/2 times the base on my right-hand side. So now I have to get rid of the 2. How do I do that? Multiply by? Yeah, what's the reciprocal of 1/2? 2. So I'd multiply by 2 on both sides, because that will cancel the 2 over here. Now I have 32 equals the base. So I am done. Any questions on how to handle those problems where you know the area and you're trying to find a missing piece? For some reason, those are the ones that people are going to get the most tripped up on, and it really is no more difficult than finding the area, right? You just have to know to put the area in on the one side and solve for a variable on the other. All right, so now we get to try working with the area of a parallelogram. So, first we should remember, what is the formula for the area of a parallelogram? What is it? Base times height, just like a rectangle, right? Do you know the base of this thing? Remember, the base is, what did I say in terms of a building? The base represents what touches the ground. So is 5 enough? No, because you have more touching the ground, right? This whole distance here touches the ground. What is that whole distance? How much? 8. How do you know it's 8? Because what? The top is 8, and it's a parallelogram, right? I guess I haven't said that, but we're going to assume it. It is a parallelogram, and so the opposite sides are going to be equal. So that's our base. Do I know my height? Is my height 5? No. Remember, we're always talking about the straight up and down height. Do I know that? I need to find this guy, right? How can I find that? All right. If I'm going to do Pythagorean theorem, I need at least 2 sides of that triangle. Yep, that bottom side is 3 because I need 5 plus this distance to add up to 8. So I now have a triangle, and I can use Pythagorean theorem, or does anyone recognize anything here? It's 3, 4, 5. So some of you guys are going to recognize that this is a Pythagorean triple, and you can just go around and put the 4. Some of you guys aren't going to see that, and that's okay. And you'll do Pythagorean theorem and set this up as h squared plus 3 squared equals 5 squared. Solving that, we get h squared plus 9 equals 25. So h squared equals 16, which means that h equals 4. So you can show that work and get to the same exact answer as the Pythagorean triple. Do I now have enough information to finish solving my formula? Yep. So let's take a look at that. What is my base? 8 times what is my height? 4, which is 32, and we're done. Biggest mistake on that is people trying to use just the 5 for the base rather than the whole 8, or people trying to use 5 for the height rather than... All right, so let's look at the next one. We've got the area of a trapezoid. It's actually really similar to the area of a triangle, and I'm going to show you another way that you can write the formula that might make more sense to you. You can write the area to match that of a triangle. So area of a triangle equals 1/2 times the base. In this case, though, we have 2 bases, right? So instead of doing 1/2 of the base, you would do 1/2 of the bases, base 1 plus base 2, times the height, just like a triangle. Notice that these two things are exactly the same. You've got a half, a base 1 plus a base 2 times a height. They're just in a different order, right? Some of you guys might like this better because it's easier to memorize in terms of that of a triangle. All right, so let's take a look at this example. This is a food tray, and we're asking how much table space area does it take up? What shape do you see in there? Trapezoid and a rectangle, right? This whole thing is not just one big trapezoid. You've got, yes, a trapezoid on top, but you also have a rectangle on the bottom. So if you're finding the area of this whole tray, what do you think we're going to do? Yep, we'll add the two together. So in other words, the area of the whole tray is going to equal the area of the trapezoid plus the area of the rectangle. So the area of the trapezoid, I'm going to kind of use the version that looks more like the triangle because that's easier for me to memorize, right? So starting out, rattle off for me the area of the triangle that you already know. 1/2. Come on, guys. A little more enthusiastic. What is the area of a triangle?
1/2 times
I'm hearing...
1/2 times base times height.
Okay, more than one person.
1/2 times base.
Okay, thank you. We're going to start getting you guys to interact a little bit more. All right. 1/2 base times height. What's the only thing that changes for the trapezoid? Two bases. Do we add or multiply them? Add. That's the only thing that changes from the area of a triangle to the area of a trapezoid. So you'll start out with 1/2. I have two bases that I have to add. What are my bases in this case? 10 and, yep, 16 are the area or the bases of my trapezoid. So add them together and we multiply that. 1/2 bases times height, right? And yeah, is that my perpendicular height that they've given me? Yeah, that's what I want, right? So that is a good height. They didn't give me the slant, so I'm good to go. Plus, and then the area of the rectangle, how do you find that? Base times height, which is 16 times 8. Very good. All right. 1/2 times, what's 10 times 16? Or 10 plus 16, sorry. 26 times 3, we'll get there in a second. What's 16 times 8? 128. All right, which number is it easier to take half of? 26 or 3? 26. So it'll be 13 times 3 plus 128. What's 13 times 3 plus 128? 167. Very good. And that is your answer. Any questions on that problem? Nope. Okay. All right, the area of a kite is if you multiply the two whole diagonals together and average them out, divide them by 2. That is the area of a kite. All right, so you guys will get figures that look like this where you have a shaded region and a non-shaded region, or like a yellow and a blue region, things like that. And you're going to be asked to find the areas of the different regions. Okay, now in this one, I just said to find the area of the shaded region, but I'm going to change that a little bit and ask you to find the area of the white region and the shaded region. Let's start by finding the area of the white region. What formula do I use to find the area of the white? Right. this is the area of a kite, right?
Is it D1 plus D2 or times?
Times, it's multiplied, yep. For that one, it is times, yep. So you would take diagonal 1 times diagonal 2 divided by 2 to find the area of that white region, right?
Okay, can we slow it down for a second? Yeah.
Okay. Oh, because you need to draw the picture, yes. Sorry. Okay, so the question is, what is diagonal 1, what is diagonal 2? So when you're looking at your figure, let's say that this is diagonal 1. How long is diagonal 1? 24, 16 plus the 8, right? So we would take 24 times distance of diagonal 2 is this guy. How big is that? Okay, and how do you know that that other piece is an 8? Yeah, because a kite has that symmetry about one of its diagonals, not both, right? But the one. So we have 8 and 8, which do add up to 16 for my second diagonal, and then we just have to divide them by 2. Nope, this is just like taking a half of something. You only take it, you either multiply the two numbers together and divide the product by 2, or you take one or the other and divide by 2. It really doesn't matter. Any way you play this, you're going to do 24 times 16 divided by 2. You should get 192 for that.
Oh, that's divided by 2.
Yep, that's with the division by 2. So now if I want to find the area of the shaded, what is going to be the easiest way for me to find the area of the shaded region now?
Rectangle minus 192.
Thank you. Yep, the rectangle minus the kite, right? Will leave me with that shaded stuff. The other way you could do this is to go around and find the areas of the triangles and add them all up. But now that you have the area of the kite, it's easier just to subtract it out of the area of a rectangle, right? The only thing we have to look at on the rectangle is what is the base times the height. So what is this distance right here? That is still 16 because of the 8 and the 8 here perfectly aligned, right? And the base is still the 16 and the 8, so 24. So when I find the area of the shaded region, we said that this is the area of the rectangle minus the area of the kite. How do you find the area of the rectangle? 16 times 24 minus the area of the kite was 192. 16 times 24 is 384 minus 192. That's just 192. So this would be the area of the shaded region, and it actually is the same exact thing as the area of the white region. That will only, well not, I don't want to say only, that does not happen in every shaded, non-shaded figure situation. So don't get caught up in that. That's just when you have a kite in a rectangle. That happens to work out that way. Okay, the next formula is the area of a rhombus. It is exactly the same thing as the area of a kite because both of these figures have that perpendicular diagonal situation. That's what allows us to use the same formula there. Something I want to point out is that there is another formula you can use for a rhombus. You just have to kind of pick it out. What if I gave you a rhombus like this? 1 second. Doesn't look like a great rhombus, but I'll mark it so that you can tell it is. And let's say that instead of giving you the diagonals, I give you this. Whoops. 1 second. This. What formula? Base times height from the parallelogram. Because a rhombus is still a parallelogram, right? So keep in mind that the area of a rhombus, you could use this formula for it, but it still also would fit with the parallelogram formula as well, depending on what information you're given. Okay, so let's find the area of this rhombus, EFGH. Given that information, what should we start by doing? Draw it. Very good. So let's draw a sketch of a rhombus real quick and then make sure that we label it appropriately. So go around the figure. You get E, F, G, H in order. So when I'm looking at this information, what is EG? What? EG is a diagonal, right? And I really can only see that by drawing the picture, so it's a good thing I drew it. And FH is another diagonal. So when I'm looking at trying to find the area of this thing, I know that I have a diagonal 1 and a diagonal 2. Which formula should I use? Very good. Yep, we'll want to use the diagonals multiplied divided by 2. So what is diagonal 1? 10, right? Diagonal 2? Okay, so if you do 10 times 15, you get 150 divided by 2, and you're done. So something really quickly to talk about, because this is on your quest next week. What is the hardest part of this section? What? Have any of the computations been hard? What's that first step that you have to be able to do? What was my first step here? What? Formula. Right? That is the hardest part in this section, is knowing all of the formulas. Like, you guys are following along in class, and as I'm going through each one, you're like, yeah, that's an easy enough formula. Don't look at it for a week. What are the chances you're going to remember them on the quest next week? Probably not very good. And if you don't know the formulas, you can't do any of the work, right? That is going to be your hardest part. How can you guys, what's a study technique you can use to memorize formulas? Note cards. I would do that. You really don't have that many. You have a parallelogram, trapezoid, kite, and rhombus, 4 note cards. Not asking too much there, am I? I would make those 4 note cards and just flip through them every now and again for the next week until you know that you have them all down. Because if you know the formula and you can look at a figure and say that's a trapezoid, here's the formula, then you can just fill in what information you know, and the math from there is really not that difficult. Okay? So keep that in mind. Here's your homework. So go ahead and take a second to write that down. And then we are actually going to do a section on similarity today as well.